The winter gatekeeper is a simple theory that if the amount of heat transported to the Arctic in winter changes in a sustained way over time, the climate will change naturally. What is heat transport? Most of the sun's energy reaches the Earth in the tropics, creating an energy surplus zone that receives more energy than it emits, shown in red in the figure. Outside the tropics, there are two energy deficit zones which receive less energy than they emit and whose size depends on the seasons. They are shown in blue in the figure and represent the situation during winter in the northern hemisphere. These imbalances should cause continuous warming in the red zone and continuous cooling in the blue zone. That this does not happen is due to the transport of heat, which also transports moisture and clouds, and is very important for the climate. The climate of any region depends on surface insolation and the transport of heat and moisture. But heat transport is a hole in our knowledge of climate. There are several reasons for this. The first is that it responds to very complicated physics, and as the scientists who study it themselves have knowledge, we do not have satisfactory theories to describe it. In addition, we are not able to measure it adequately because it takes place all the time in the atmosphere and in the ocean, and it varies greatly through the year. From satellites, a global calculation of heat emissions is made, but we cannot distinguish the variations in what is transported by the atmosphere and by the ocean. Seasonal variation is very important because of the tilt of the planet's axis. Much more heat is transported in the winter than in the summer, and some of that heat goes in and out of the ocean without being adequately measured. Because we know almost nothing about heat transport, the models know nothing, and although they can be made to reproduce the total amount transported, they are not able to do so in the same way as the climate. Despite this lack of knowledge, most scientists believe that variations in heat transport have not contributed to recent climate change. Why do they hold this belief based on lack of knowledge? The first reason is that when heat is transported horizontally within the climate system, the amount of heat contained in the system is not changed, and that heat continues to produce the same infrared emissions to space. Therefore, heat transport cannot cause a change in global climate, only regional changes. Is this true? Actually, it is not. It is rarely mentioned, but 75% of the Earth's greenhouse effect is due to water vapor and clouds, and their distribution by latitude is extremely uneven. The tropical atmosphere contains a lot of water and clouds, and the polar atmosphere in winter contains almost none. Therefore, the greenhouse effect in the polar regions is extremely small, and the transport of heat from the tropics to the Arctic changes the emissions. This means that the total is not constant, so heat transport has the ability to change the global climate. If the total amount of heat transported were always the same, the transport would not cause climate change, and this is what many scientists believe. They believe that as heat transport through the atmosphere increases, heat transport through the ocean decreases, compensating for the change, and the total amount does not change. This theoretical compensation, which has never been proven, appears differently in each model without knowing its physical basis. This means that for these scientists and models, transport is not a cause of climate change. But again, reality is different. Heat transport can increase in the atmosphere and also in the ocean, changing the amount of energy transported. In fact, this is logical because most ocean transport is due to surface currents driven by wind, which is also responsible for heat transport through the atmosphere. If the wind increases, the transport in both compartments must increase. This is also supported by Arctic heat transport data from two studies. Both atmospheric and oceanic heat transport increased in the early 21st century. According to theory and models, this is not possible, and yet the effects of this increased heat transport could not be clearer. In the Arctic, winter temperatures have risen sharply. Obviously, this heat must be transported there, because the sun does not shine in the Arctic in winter, so no heat is generated. So the theory is simple. Any cause that can change the transport of heat can change the climate. And what are those causes? The evidence suggests that there are at least 7 causes capable of altering heat transport. From longest to shortest duration, we will have plate tectonics, the effect of orbital changes, solar variations, multidecadal ocean oscillations, volcanic eruptions, El Niño Southern Oscillation, and the quasi-biennial oscillation. The general mechanism when the coast promotes warming, such as high solar activity, is to reduce heat transport to the Arctic in winter, and this causes temperatures to drop, reducing infrared emissions to space that allow heat to escape from the Earth. The result is that the planet conserves more energy, which can lead to warmer temperatures. If the coast promotes cooling, such as low solar activity, it increases heat transport to the Arctic, causing it to warm. This warming increases emissions to space, causing the planet to conserve less energy. The result is that the planet either warms more slowly or cools, depending on other factors. There is much evidence to support this theory, from the behavior of the stratosphere in response to changes in solar activity, volcanic eruptions, or the El Niño phenomenon. But the clearest evidence comes from the Arctic. There have been many periods of Arctic warming in the past that have coincided with periods of low solar activity. So the telltale evidence is the Arctic winter temperature and the frequency of very cold winters in eastern North America and eastern Eurasia. One prediction of the theory, which is absolutely incompatible with those based on increased CO2, is that the Arctic will cool when there is a very active solar cycle again. Nevertheless, it should not be very difficult to prove that the theory is true. It is sufficient to better study the changes in heat transport and emissions in the Arctic. Of course, the models will not confirm it, because the models do not reproduce the heat transport correctly. Thanks for your attention. If you like climate science and want to know more about it, you can buy my books, which are available at Amazon and other internet stores. You can also subscribe to my YouTube channel.